Thank you, thank you. 1, 2, 1, 2. Can you hear me? All right. Does this work? Let me check. It does work. All right. Hi, everybody. My name is Emmanuel. I'm the founder of a company called Airtrain.ai. We have a booth over there. You can try our free playground. You can interact with different models. I'm going to show you how it works today. So today I want to talk about the process of looking at those various LLMs that are out there. So as you all know, at this time, GPT-4 is still the undisputed king of models. It performs the best on almost all tasks. It's the first model to try when you're trying to prototype an AI product. They always say, if it doesn't work with GPT-4, you can just forget about it, okay? So it is definitely the best place to start when you're trying to prototype an AI product. But it's not all perfect. Yes, it's great, but it's also very slow. If you take this data from artificialanalysis.ai, you will see that GPT-4 is actually pretty slow compared to other alternatives out there. It's also very expensive. GPT-4 is the most expensive model on the market. So it makes it a very good model for prototyping, see if your idea even works in the first place. But as soon as your idea works and you build out your product and you start scaling out, you start getting more users onto your application, you're going to have a huge bill to pay to OpenAI at the end of the month. So obviously that's not ideal. On the other hand, as you've heard today multiple times, small models can perform very well. This was proven last year by Microsoft with this paper called Textbooks Are All You Need. This was the Phi-1 model. Phi-1 is a very small model, it's a couple of billion parameters. Essentially, they generated some very high quality data set using GPT 3.5 to do synthetic data generation and also scrape the internet for textbook quality data. And so they have this very small model, about 1.3 billion parameters, very high quality data set, synthetic data, and they fine-tuned the model on this data. And the performance is on par with the best in class. At the very bottom here, you have Phi-1, and you can see the results on the human eval coding benchmark. And the only two models that are beating Phi-1 are GPT-4 and Wizard Coder. All the other ones, even though they're bigger models, do not beat Phi-1. So the point I'm trying to make here is if you take a small model, fine-tune it on a very high quality data set for a specific use case, you can have performance that is on par with large models. Another example is the tiny models paper that came out in April last year. This is a more extreme use case because the models are even smaller. If you look at the model sizes in the header row there, is counted in millions of parameters, so very small, and the reference model is the 1.5 billion GPT-2 model. What they did is that they generated a high quality data set of stories for children and fine-tuned very small models on that, and then got the model to complete stories. And it turns out small models perform better than GPT-2. So again, small models, when fine-tuned on a high-quality data set, can bring performance on par with large models. So how, as an industry, as a community, how do we get away from GPT-4? GPT-4 has its place. It's your prototyping model. But how do we get away from it? Well, the first step is to start with evaluation. You have to explore the other options out there. So there are two practices that are common when you do evaluation. The first one is called the vibe check, where you're just getting a sense of how those other models perform. So you just want to prompt them manually. Maybe you have a set of a dozen prompts that you usually try on those models to get a sense at a high level of how those models perform. Once you have this high level sense, this intuition that you've built, you need to move on to batch evaluation. Batch evaluation is when you create a batch evaluation data set of a few hundred or a few thousand examples, and you run them all through the model to have some statistical significance about this. Intuition is great, but intuition is not statistically significant. So once you've built your intuition, you need to move on to batch evaluation. So I'm going to quickly show you how you can do those things with Airtrain. So the first thing I want to show you is the Airtrain Playground. You can try it for free over there at the Airtrain.ai booth. This is a free product. You can actually sign up right now and use it for free. You can put up together a number of models, some open source ones, some proprietary ones, and you can prompt those models at once and see how they perform. In this case, I asked those models to write a very short message to welcome attendees to the AI user conference in San Francisco. And as you can see, all the models return some reasonable outputs. Okay, that gives me a vibe check. Those models are reasonable, they're coherent, they can speak English correctly. Let's move on now. So how do they do on reasoning? Are they able to think complex problems? This is a common riddle that is used to try to make LLM fail. Here's the riddle. Julie is a girl. Julie has 3 brothers. Each brother has 2 sisters. How many sisters does Julie have? For us humans, this is pretty easy to figure out. Julie has 1 sister. It's pretty straightforward. Turns out, most models cannot figure this out. Even the best models here, GPT-4, get it wrong. Julie has no other sisters. Even though when you read the answer, it seems like the model has understood the problem, but gets the wrong answer. So all those models get it wrong. Okay, so what can we do to get it right? Well, there is one common practice in prompt engineering, and that's chain of thought. So you're basically asking the model to explain their reasoning. So this is the same prompt, but I'm adding this green component to it. Please explain your reasoning step by step. So obviously the responses are longer because the models need to explain all those reasoning. But now you can see that Mistral Medium and GPT-4 actually get it right. Okay, I can see that now some of those models actually get it right, are doing a good job at reasoning, but I had to add this chain of thought prompt to it. So another example is arithmetic. Something that is fairly easy for us to do as humans may not be as easy to do for a model. So here I'm comparing 3 small models. I have Llama 7B on the left, Mistral 7B in the middle, and Phi 2, which is a 3B model in the middle. As you can see, all of them fail. None of them get it right. Okay, well, that's kind of disappointing. Let's see how the big models do at it. So here I'm comparing Llama 2 70B, so the big variant of Llama, Mistral Medium, GPT-4, and Gemini Pro. They all get it right. Okay, so that tells me something. It tells me that if I care about arithmetics, then maybe those bigger models do best than the small ones, or I'm going to have to do some work on those small models. So this is the concept of the vibe check. You get a quick sense of how they do. Here's an example on JSON extraction. So I am passing a news article, like a CNN news article, and I'm asking the models to extract 3 highlights and format them as a JSON payload. So you can see the response for all of them, and you can see that Llama 2 doesn't even get the highlight extraction correct. It's actually wrong. It's just giving me a number of words from the model. And then Phi 2 also doesn't get the highlight extraction correctly. It doesn't even get the JSON payload right. And then OpenAI, okay, gets the highlight extraction right. The JSON payload is right. However, I asked the model a specific output with backquotes to make it stylable, and then only Gemini gets it right. So here it is. This is our vibe check with various tasks that we're interested in: arithmetic, reasoning, and it's up to you to figure out what matters to you and prompt those models. So now that I have this general sense of how those models perform, the right scientific thing to do is to prompt those models at scale. So send similar prompts in large amounts to those models to have some statistical significance. So we have at Airtrain this batch evaluation product that lets you do just that. You can upload a data set of thousands and thousands of inputs, and then you can configure multiple models to prompt those inputs, and then you can grade the outputs of those models. So you have to score the output of those models. At this time, the best way to evaluate the performance of various LLMs on specific tasks is to get another model, a scoring model, to evaluate those outputs. It's called LLM as a judge. So essentially you use another model to score the outputs. So here we're going to evaluate a number of models, again on the same riddle, the sister riddle. And what I want to test is whether those models are consistent. We saw that Mistral Medium and GPT-4 got this riddle correctly. Do they get it correctly every time? If I ask the same questions 100 times, are they always going to give me the right answer? Because, models are stochastic creatures. They don't always give you the same answer for the same question. So here, I'm going to prompt those models 100 times with the same riddles. And the way that I'm going to evaluate if they're correct is I'm going to ask my scoring model. Here, the score represents the number of sisters that Julie has according to the chatbot. And here, I provide a rubric to help the model score the output. And then, so a score of 1 means that the chatbot said that Julie has 1 sister, score of 2, 2 sisters, and so on. So now let's take a look at the results. So here, bottom left, you can see the definition of the score, and you can see the plot here. So if you remember, a score of 1 means that the chatbot has evaluated that Julie has only 1 sister, so that's the correct answer, and all the other answers are incorrect. So here I can see that GPT-4, again, is the best one here. GPT-4 has almost 100%. Almost 100% of the time when I prompted GPT-4 with this riddle, got the answer correctly. Not 100% though. You can see that you don't have the number here, but this point is not exactly 100%. So sometimes GPT-4 will get it wrong. And then you can see that Mistral Medium is also mostly correct, probably around something like 88%. So 88% of the time, Mistral Medium will get it right, sometimes will get it wrong. And then Llama 270B is just flat out wrong all the time. So this is what you need to do to evaluate models at scale. Having your vibe check is important to build your own intuition, but eventually you need to throw hundreds, if not thousands of input data at those models to get a statistically significant sense of how those models perform. Okay, so you can get started for free with those 3 products. This playground is free for you to use. Just sign up now and get started. Batch evaluation is also free. We also offer fine tuning so that you can start refining those smaller models to perform as well as those bigger models. So get started now for free. We also have a YouTube channel where we produce weekly content about AI news, tutorials on how to get started with certain models. So subscribe now to our YouTube channel. And with this, thank you very much. I'll be hosting a workshop at 3 p.m. this afternoon to show you how to do this this kind of vibe check and batch evaluation. This kind of thing is going to be in that room over there. And we have our booth right there, so come say hello. And thank you so much.